a resistor in series with a capacitor in a direct current circuit. So we have a 12-volt battery, 300 kilo ohm resistor, and a 22,000 microfarad capacitor. Now let's see what equations apply. Because we have a capacitor, of course, the charge of the capacitor, Q, does equal C times B. And now a new definition, time constant is a product of resistance and capacitance for an RC circuit. And what's true about current at one time constant? The current is equal to 0.37 times the beginning current or the maximum current. And then the charge is going to be equal to 0.63 multiplied by Q max, or the maximum charge the capacitor can hold. Okay, and then there are some time equations for current and charge. Current at any time is equal to current max multiplied by E to the minus T over the time constant RC. Now there's also a charge at time equation. So charge at time T is equal to Q max multiplied by 1 minus E to the T divided by RC. So these are the equations that we can use, okay, for a circuit that is an RC circuit in a DC situation. Let's go ahead and solve some of these right now. So time constant for the circuit is going to equal the resistance 300 times 10 to the third, that's the kilo ohm resistor, multiplied by 22,000 times 10 to the minus 6, because it's a microfarad capacitor. The time constant for the circuit is going to equal 6,600 seconds. So let's go ahead and get our charge maximum and get our current maximum. When the circuit's turned on, the resistor holds all of the current, and there's no charge on this capacitor at all, so we can pretend that it does not exist initially. So we just use Ohm's law to get maximum current. So I'll go 12 is equal to I times 300. And the current, in this case, is 0.040 milliamps. Now you might be wondering, why did I put this in regular ohms here but not down here? It's because we need base units in our time constant equation, but we don't in everything else that we do. And we can just record milliamps. Now what about charge maximum? So charge maximum, or Q max. Now, when this capacitor is totally full, all of the volts will be on it, and there will be no volts on this resistor because the current would have dropped to 0. So then what I'll do is I'll say my charge maximum is C times B, so 2200 or 22,000. We'll multiply that by 12. And that will give us a value of 264,000 microcoulombs. Now you're, of course, welcome to convert that to a different unit if you like. I'll just keep all of mine in microcoulombs. Okay, now let's find the charge at one time constant and find the current at one time constant. So then the current at one time constant will just be 37% of the maximum current. So I'll say 0.37. Multiply that by 0.040 milliamps. And that's going to equal 0.015 milliamps. Now the charge at one time constant then would be 63%, or 0.63, multiplied by our maximum current, or maximum charge of 264,000. Okay, and that is going to equal 160 66,000 microcoulombs. And that's how you handle the charge and I guess the charge voltage and anything else that you want to think about in current, okay, for an RC circuit. In our next video, we'll look at how we handle these two equations here, where you don't have it just at one-time constant. Okay?